Hello, in this video, we're going to focus on adding and subtracting mixed numbers and improper fractions with unlike denominators. This first problem here, we have 2 1/2 plus 1 1/4. Now, there are three ways I'm going to show you how to solve this problem. The first way I'm going to show you is using a visual model. So I'm going to first take 2 1/2, and I'm going to draw a picture of what that looks like. So we're going to draw circles here. I have one full circle, a second full circle representing my two holes, and now I have 1/2. So that's telling me I have one piece of a hole. Now, notice it's 1/2, so I broke that circle into two equal pieces. I'm going to shade in 2 1/2 using blue. So here I have one hole, two holes, and my third one is not fully shaded in, just one piece of it is. And notice I'm going to actually break each of these circles into two equal pieces. Now this visual here shows you that this is what 2 1/2 represents. Now, every mixed number we can also represent as an improper fraction. So if I counted how many halves I have here, I have 1/2, 2 halves, 3 halves, 4 halves, 5 halves. So in fact, I can also represent 2 1/2 as an improper fraction known as 5 halves. Now, I'm going to do the same exact thing for 1 1/4. So 1 1/4, again, my denominator this time is 4, which is telling me I'm going to break these circles into 4 equal pieces. So I'm just going to draw 3 here. Now what I'm going to do is let me shade in 1 1/4. So I have one full circle, and then I have 1/4. So I have one piece shaded in, one out of the 4 pieces. Now, even though I have this third circle here, I'm not using this because my mixed number is 1 1/4. Now, just like the previous number here, we can also represent 1 1/4 as an improper fraction. So let's count how many fourths I have. 1/4, 2/4, 3/4, 4/4, and 5/4. Notice both these mixed numbers and improper fraction represents the same visual model because every improper fraction can be represented as a mixed number and every mixed number can be represented as an improper fraction. Now my next step is to add everything together. So by looking at these models here, I notice that my top model, 2 1/2, has everything broken into 2 equal pieces, while my bottom part has everything broken into 4 equal pieces. Now, before I do any adding or subtracting, I need to make sure that everything is the same size. So what I'm going to do here is I notice that I have my halves here. If I draw a line going this way, now I'm actually breaking this exact same picture, not into 2 pieces, but now I'm creating 4 equal pieces. And if I do that to each of these, let's see, here I can do the same thing. I'm breaking this into 4 equal pieces. And over here I have 2 pieces. Now I have 4 equal pieces. Notice I didn't change the amount that was shaded. I didn't change anything here besides breaking the same amount into different size pieces. Now notice this is creating an equivalent fraction. So now when I have 2 1/2, I can also represent 2 1/2 as 2 fully shaded circles. And instead of 1/2, I notice I have 1, 2. I have 2/4 shaded in. But notice when I represented 2 1/2, it's equivalent to 2 2/4. I just changed that visual model just a little bit to create an equivalent fraction. Now when I'm looking at all of these circles here, I recognize that everything is exactly the same size. I now have 2 2/4, and I have 1 1/4. Now, just like when we were adding and subtracting proper fractions, we notice that my denominators are the same, showing me that everything in this model is broken into fourths. So So now I can just combine everything together. Now, the first thing when I'm using a model is I look at what's fully shaded in. How many holes do I have? What is my whole number going to be? So let's see. I have 1, 2, 3. I have 3 fully shaded in circles. That's my whole amount. I notice that every single circle here is broken into 4 equal pieces. And now I'm going to look at the amount that didn't create a hole. So I have 1/4 here, 2/4, 3/4. And that's telling me that my numerator here is going to be 3. The answer to this problem is 3 and 3/4. Notice I simply combined all of these amounts together to create my answer. Now, I can also choose to count how many fourths I have. Well, I know 1 whole is the same thing as 4/4. So I have 4/4, 8/4, 12/4. Now let's count here. 13/4, 14/4, 15/4. So I can also represent my answer as 15/4. Both options are correct. So now what we're going to do is we're going to do this exact same problem, but this time I'm going to simply just add the mixed numbers. I'm not going to draw out a visual model, but I'm going to show you another way to do this. So we have 2 1/2 and 1 1/4. From the previous problem, using that model, we recognize that I can change 1/2 to 2/4. 1/2 and 2/4 are equivalent fractions. You might also recognize that 4 is my least common denominator. Now let's say if I couldn't identify that really quick, I can take my 2 denominators and let me list out my multiples. 2, 4, 6, 8, 10, 12, 4, 8, 12. Now, right away, I recognize, whoa, 4 is my least common denominator. 8, 12, and you'll find that there's many more common denominators. But it makes it a little bit easier when we choose the least common denominator. It's not wrong if you choose 8, 12, 16. Those are all great denominators as well. But I do encourage you to try using the least common denominator. So now I know that my denominators need to both be 4. Now, just because I have a mixed number, we're still going to do the same process. Now, this whole number of 2, we have to still include it. We can't just eliminate it. We need to include that in the problem. So when I'm looking at my denominator, I'm like, 2 times what number gave me 4? Well, 2 times 2 is 4. So if I multiply my denominator by 2, I do the same to my numerator. So 1 times 2 is 2. Now I look at my denominator here and I'm like, wait, I actually have 4. So looking at this denominator here, I already have 4. So in fact, I can leave this fraction exactly how it is. Now my final step is to add everything together. As you know, your denominator is going to stay exactly the same. We're going to simply add my numerators. 2 plus 1 is 3. Now this process here you've been doing all along. Now we're just adding one more step in. We can't forget about those whole numbers. So 2 plus 1 is 3 and 3/4. And that is all you need to do. Now, if we look back at the previous problem, we see, wow, we got the same answer using my visual model or using more of a standard algorithm. Now, I'm going to take this exact same problem again, and this time I'm going to use my improper fractions. We learned from the visual model that 2 1/2 is equivalent or equal to 5 halves. Also, 2 times 2 is 4, plus 1 gives me 5 with the same denominator of 2. We also learned from the visual model as well, 1 1/4 is the same as 5/4. Now, in the last problem, I set up my problem vertically. Some of you might prefer to set it up horizontally. So I'm going to do this horizontally. Now, even though we have improper fractions, we're going to do the same methods. I learned from the last 2 problems that 4 is in fact going to be my least common denominator. Now, let me do this in red here. So 2 times what number gives me 4 as my denominator? 2 times 2. If I multiply my denominator by 2, I do the same to my numerator. Doesn't matter if it's a proper or an improper fraction, it's the same process. 5 times 2 is 10. Now I notice here I have 4, and I already have 4 as well as my denominator. So notice I'm not changing this fraction. I'm just rewriting it to make it a little bit easier when I'm solving. Now I recognize my denominators are exactly the same. That's great. We need that before we add. And now I look at my numerators. 10 plus 5 gives me 15. Now notice this is the exact same answer. 15/4 is equivalent to 3 3/4, and we prove that in this problem using the visual model. That's telling me that I solved this problem correctly. Now, when you are given a mixed number, you are welcome to use any of these 3 approaches. Some of you might love keeping it as a mixed number, and depending the problem given to you, you might need to keep it a mixed number. Some of you might love to do it as an improper fraction. And again, depending on the situation, it might be easier to leave it as an improper fraction. It is up to you, but these methods work for either way. So now we're going to do the exact same problem, well, a little different numbers this time, but we're going to subtract, because I want to show you that you're doing the same process whether you're adding or subtracting. So now let's take a look here. We have 4 1/2. I'm going to set this one up vertically. And 2 2/5. I recognize I have subtraction. Always look at your operation symbol before you begin. Now I'm taking a look at my denominators. I see I have 2 and I have 5. They're different denominators, so now I need to change both these fractions by using equivalent fractions so they have the same denominator. Let's start by finding my least common denominator. 2, 4, 6, 8, 10, 12. Notice I listed out my multiples. 5, 10. Oh, wait, I stopped there. Now I stopped there because I recognize 10 and 10 is in both columns. Therefore, 10 is my least common multiple. So let me just write that out. I'm like, I know my denominators are all going to be 10. How great is this? Now, because I have a mixed number, I still need to include my whole numbers here. So it's important we still include this here. Now, my final step. Let's see, 2 times what number gives me 10? Well, 2 times 5 is 10. If I multiply my denominator by 5, I do the same thing to my numerator. 1 times 5 is 5. Now I'm going to look at my next problem, 2/5. 5 times what number gave me 10? 5 times 2, I multiply my denominator by 2. I do the same thing to my numerator. 2 times 2 is 4. So now 2 times 2 is 4, which is my new numerator. Now my final step. I notice my denominators are the same. I created equivalent fractions. That's changing both of these mixed numbers so they have the same denominator. Now I look at my numerator and I subtract. 5 minus 4 is 1. Now you guys have been doing problems like this all along. Now we're just adding in that extra step. I can't forget about my whole numbers. So 4 minus 2 is 2, giving me a final answer of 2 1/10. Now, this is one way you can do it. This is an excellent way to do this work. You can also choose to draw out visual models. You can also choose to change this as an improper fraction and then subtract as well. Either way works. You pick what way works best for you. As always, I encourage you to refer back to this video at any time when you are adding and subtracting mixed numbers or improper fractions with unlike denominators.